Jupiter, the king of our solar system, reigns over a vast collection of moons. Among them is a small, enigmatic moon discovered in 2003, known as S2003 J10. This tiny world holds clues to the early solar system and the dance of gravity. S2003 J, the 10th of May, seem insignificant at first glance, but even the smallest celestial bodies can reveal grand secrets. S2003 J10 is part of a group called Irregular moons. Their orbits are distant, elliptical, and often tilted. These characteristics hint at a history shaped by capture. The discovery of S2003 J10 marked another triumph for modern astronomy. In 2003, a team of astronomers led by Scott S. Shepard embarked on a survey of the outer Jovian system. Using the powerful Subaru telescope in Hawaii, they scanned the sky for faint points of light moving with Jupiter. Their meticulous observations paid off. The team spotted a faint object moving across the starfield. Its slow, looping motion indicated it was gravitationally bound to Jupiter. Further observations confirmed its identity as a new moon, adding to Jupiter's already impressive collection. The discovery of S2003 J10 highlighted the power of modern telescopes. They allow us to detect incredibly faint objects in the vastness of space. The discovery of S2003 J10 was not a singular event. It was part of a larger effort to map the outer Jovian system. This ongoing search continues to reveal new moons. Each discovery adds a piece to the puzzle, helping us understand the complex history of Jupiter and its surroundings. S2003 J10 stands out from Jupiter's other moons due to its peculiar orbit. Unlike the inner moons, which gracefully waltz around Jupiter, S2003 J10 traces a wild and eccentric path. Its orbit is highly elliptical, taking it far from Jupiter before swinging back in a close approach. Adding to its rebellious nature, S2003 J10 has a retrograde orbit, circling Jupiter in the opposite direction of the planet's rotation. It takes approximately 734 Earth days for this tiny moon to complete one orbit around Jupiter. Unmasking the mystery moon size, composition, and the unknown. Despite its intriguing orbit, much about S2003 J10 remains a mystery. Its small size, around 2 kilometers in diameter, makes it hard to observe, like studying a grain of sand from miles away. Scientists think S2003 J10 is rocky, similar to asteroids. Its surface is likely heavily cratered, bearing scars from billions of years of impacts. Future telescopes could reveal more about its composition. Cosmic captives, irregular moons, and the capture theory. S2003 J10 belongs to a fascinating group of objects known as irregular moons. These moons are defined by their distant, eccentric, and often inclined orbits. Unlike regular moons, which formed from the same disk of material as their parent planet, irregular moons are thought to be captured objects. They were once independent bodies, perhaps asteroids or comets, that strayed too close to a planet and became ensnared by its gravity. The capture theory explains the unusual orbits of these moons. When an object is captured, its original path is altered by the planet's gravitational pull. This can result in the highly elliptical and inclined orbits we observe today. The capture process is a chaotic dance, often involving interactions with other moons or planets. The study of irregular moons like S2003 J10 provides valuable insights into the early solar system. By analyzing their orbits and compositions, we can learn about the conditions that existed billions of years ago when planets were still forming and capturing smaller objects. Unraveling the secrets of S2003 J10, future exploration and discoveries. S2003 J10, despite its small size and remote location, holds great potential for future exploration and discovery. While it is unlikely to be a target for a dedicated mission anytime soon, advanced telescopes and future space probes could provide valuable data that enhances our understanding of this enigmatic moon. As technology advances, telescopes will become even more powerful, enabling us to study S2003 J10 in greater detail. We can analyze the light reflected from its surface to determine its composition, search for signs of geological activity, and refine our understanding of its orbit and rotation. These observations could reveal unexpected details about its history and formation. Future space missions to the outer solar system could also provide opportunities to study S2003 J10. While not the primary target, a probe could conduct flyby observations, collecting valuable data on its size, shape, and surface features. These missions could also search for the presence of any faint rings or moonlets that may be associated with S2003 J10.